Children of the Stars, the universe's bedtime story. Brought to you by WonderDriftStories. Settle in. Let your body sink a little deeper into wherever you are right now. Take one slow breath in and let it go. Tonight, we're going somewhere vast, somewhere ancient, somewhere so staggeringly beautiful that physicists spent their entire lives trying to find the words for it. Tonight, we're going to explore the universe, not with telescopes, not with equations, just with wonder. Part 1. The Size of Everything. Before we begin, I want you to consider something. Right now, as you lie here in the quiet, the universe stretches out around you in every direction, 93 billion light-years wide. That number is almost meaningless to our minds, and that's okay. Some things are too large to hold in a single thought. But let's try. Our home, planet Earth, is a small, warm rock orbiting an average star we call the Sun. That star sits inside a galaxy containing over 100 billion other stars. And that galaxy, our Milky Way, is just one of over 100 billion galaxies scattered across the observable universe. 100 billion galaxies, each one containing hundreds of billions of stars, each star potentially warming its own family of planets. And all of it, every last atom, has been here for 13.7 billion years, slowly arranging itself into the universe you and I are part of tonight. There's something Professor Brian Cox once said that I find deeply comforting before sleep. He said, "When we look out into space, we are looking into our own origins, because we are truly children of the stars." We'll come back to that thought. But first, let's go back to the very beginning. Part 2. The Big Bang. 13.7 billion years ago, there was nothing. No space, no time, no darkness. Because darkness requires space to exist in. Just nothing. And then, in a moment that defies every intuition we have, everything began. Not an explosion into empty space, but the creation of space itself. Every point in the universe rushing away from every other point, in all directions simultaneously. The Big Bang. In the first fraction of a second, a fraction so small it has no name in everyday language, the universe was unimaginably hot. 1,000,000,000,000 degrees. A sea of pure energy with no atoms, no stars, no light as we know it. Just raw, furious possibility. Within the first 3 minutes, the universe had cooled enough for the simplest atoms to form. Hydrogen, helium, the first 2 elements in existence. For the next 380,000 years, nothing you or I would recognize. Just a thick, hot fog of particles, so dense that light couldn't even travel through it. The universe was opaque, blind to itself, And then, slowly, it cooled. The fog cleared. And for the first time in the history of everything, light traveled freely across space. That ancient light still exists. Right now, it fills the entire universe as a faint background glow, the cosmic microwave background, a whisper from 13.7 billion years ago, still echoing through the cosmos like the last breath of a very old dream. Take a slow breath. That light is older than the Earth, older than the Sun. It has been traveling since before our solar system existed, and it is still out there right now as you rest. Part 3. The First Stars. For a long time after the fog cleared, the universe was dark. There were no stars yet, just vast clouds of hydrogen gas, slowly, gently, drifting together under the pull of gravity. This period is called the Cosmic Dark Ages. Imagine that. Billions of years of darkness. The universe, patient and quiet, waiting. Then in pockets across the cosmos where gas had gathered thickest and densest, something remarkable began to happen. Gravity pulled the gas inward, tighter, denser, hotter, until, at the center of these collapsing clouds, the temperature became so extreme that hydrogen atoms began to fuse together. Two hydrogen atoms pressing so hard against one another that they merged, releasing an enormous burst of energy. A star was born, the first light in a dark universe. And as Brian Cox once described it so beautifully, every carbon atom in every living thing on the planet was produced in the heart of a dying star. Think about that as you begin to drift. The atoms in your hands, in your chest, in your breath right now. They were forged inside stars that lived and died billions of years before the Earth existed. The 92 elements that make up all life on Earth were created by the lives and eventual deaths of distant stars, forged deep in their burning core, then scattered across the universe when those stars exploded, supernovae, the most violent events in the cosmos, sending their gifts of carbon, oxygen, iron, and calcium drifting through space. Eventually, some of that stardust found its way into a quiet corner of the Milky Way. It gathered, it swirled, it formed a new star, our Sun, and the leftovers became the planets. One of those planets became the Earth, and on that pale blue dot, after billions of years, that stardust arranged itself into something extraordinary, into life, into you. We are the cosmos made conscious. Life is the means by which the universe understands itself. Let that settle over you like something warm. Part 4. Light and time. Here is something that might gently bend your mind before sleep. When you look up at the night sky and see a star, you are not seeing it as it is. You are seeing it as it was. To look up is to look back in time, because the ancient beams of light are messengers from the universe's distant past. Light travels fast, 300,000 kilometers every second. But the universe is so vast that even at that speed, light takes an enormous amount of time to reach us. The moon? That light is about 1.3 seconds old. The sun? The nearest star beyond our sun, Proxima Centauri? That light left home 4.2 years ago. The stars you see with the naked eye on a clear night. Most of that light is hundreds or thousands of years old. Some of those stars may no longer even exist. They could have already died, collapsed, exploded, faded, and we simply haven't received the news yet. The universe communicates at the speed of light, and the universe is very, very large. There is something deeply peaceful about this, if you let it in. We are all, in a sense, time travelers. Every time you look at the sky, you are receiving light that has crossed the void for hundreds of years just to reach your eyes. The universe has been sending you messages your entire life. You just have to be still enough to notice. Be still now. Part 5. A black hole. Let's visit one of the strangest places in the universe. A place where the laws of physics, as we understand them, simply stop working. A black hole. When a star much larger than our sun reaches the end of its life, it collapses under its own gravity in a fraction of a second. The implosion is so violent that nothing, not matter, not energy, not even light, can escape. The gravity becomes so extreme that it bends space itself. At the very center lies what physicists call a singularity, a point of infinite density where our equations break down and we simply don't know what happens. Around it sits the event horizon, an invisible boundary. Cross it and you cannot return. Not because of a wall, not because of force, but simply because all paths forward lead deeper in. There is no direction that points back out. It is a one-way door written into the geometry of the universe. And yet, black holes are not empty nothings. The largest ones, the supermassive black holes, sit at the centers of most galaxies, including our own Milky Way. Ours is called Sagittarius A, and it contains the mass of 4 million suns. It sits at the heart of our galaxy, patient, ancient, enormous, slowly pulling dust and gas into its depths. And somehow, impossibly, it helped shape the very galaxy that gave birth to our solar system. The universe has a way of making the terrifying also beautiful. Rest with that. Part 6. The destiny of the universe. Now, let's look forward. Not weeks or years, but billions upon billions of years. What becomes of all of this? Our sun, like all stars, will one day run out of fuel. In about 5 billion years, it will swell into a red giant, enormous, luminous, before collapsing into a cool, dense ember called the white dwarf. The other stars across the universe will do the same, one by one, across unimaginable stretches of time. Slowly, the universe will grow darker. Eventually, after a period of time so long that it makes the current age of the universe feel like a single heartbeat, the last stars will flicker out. There won't be a single atom left. All that's left will be particles of light and black holes. After an unimaginable period, even the black holes will have evaporated. The universe will be nothing but a sea of photons gradually tending to the same temperature as the expansion of the universe cools them towards absolute zero. Nothing happens, and it keeps not happening forever. The arrow of time has simply ceased to exist. This is called the heat death of the universe. It sounds lonely, but I find strangely that it isn't. Because right now, in this moment, the universe is alive. Stars are being born. Planets are spinning. Somewhere, perhaps, life is looking up at its own night sky and wondering the same things we wonder. We are here in the middle of the story, not at the end. And that is a remarkable place to be. So here we are, a tiny planet, a single star, one small corner of a universe 93 billion light years wide. And yet, we are the mechanism by which meaning entered the universe, if only for a fleeting moment in time. Every atom in your body has been on a 13.7 billion year journey to be here, in this moment, at rest. The carbon in your bones was forged in a dying star. The iron in your blood was scattered across space by a supernova. The water in your body carries hydrogen that has existed since the first 3 minutes after the Big Bang. You are, in the most literal sense, made of ancient starlight. So as you drift off tonight, let your mind wander outward, past the moon, past the sun, out through the spiral arms of the Milky Way, into the vast, quiet dark between galaxies, where the universe hums with the memory of its own beginning and rests, just as you rest now. Good night.